Here we are in section 7-2 exercises, numbers 40 through 45. It says rationalize the denominators. Notice each of these denominators is a binomial, and the secret to rationalizing a binomial denominator harkens back to chapter 5 where we had a difference of squares, a squared minus b squared. Anytime we wanted to have no middle terms, it had to be factored into what were known as conjugates, a plus b, a minus b. So the idea is when you multiply these two together, there are no middle terms, and the first is a perfect square and the second is a perfect square. Notice what happens here. That's exactly what we have. We're trying to get so that we don't end up with a square root on either of those terms, and certainly no middle terms. So we're going to be multiplying by the conjugates. So if we have 5 plus the square root of 2 here, we're going to multiply by 5 minus the square root of 2 on top and bottom. 5 minus the square root of 2. And what does that give us? That gives us 7 times 5 minus the square root of 2 over, now let's look at the bottom here. 5 times 5 is 25. 5 times minus square root of 2 is minus 5 square roots of 2. Positive square root of 2 times 5 is positive 5 square roots of 2. And plus times a minus is minus square root of 2 times square root of 2 is square root of 4. Now notice the magic that has just happened by these conjugates. The plus and the minus ensured that that guy and that guy are gone. We have no square roots in the denominator now. And we have 25 minus, what's square root of 4? That's a 2. Exactly. See this? We get square root of 2. This is a perfect 2. When you multiply by conjugates, both the a gets squared, the 5 got squared to the 25, and the b got squared. So the square root of 2 got squared to a 2. 25 minus 2 is 23. So we get 23 on the bottom, and we could just distribute this guy in now. 35 minus 7 square roots of 2. That becomes our answer, where the denominator is now rational. There are no square roots in it. Good. All right. The conjugate of 7 minus the square root of 5 is 7 plus the square root of 5. So notice we're not using the exact thing that is there, but we're using its partner to help pull everything out of the irrational world. So we get 3 times 7 plus the square root of 5 on top. And on the bottom, we get 7 times 7 is 49. 7 times plus the square root of 45, plus the square root of 5 is 7 square roots of 5. Minus square root of 5 times 7 is minus 7 square roots of 5. And minus square root of 5 times square root of 5 is square root of 25. Square root of 5 times square root of 5 is, yep, you got it, it's 5. And these two cancel. The magic happens again. We get 49 minus 5. That's a 44 on the bottom. And then go ahead and distribute that guy. And we get 3 times 7 is 21 plus 3 square roots of 5. Yes, good. Okay, number 42. We're going to do the conjugate here. 2 minus 5 square roots of 7. We're going to times that on top and bottom. 2 minus 5 square roots of 7. Yeah, okay. So we get 6 times 2 minus 5 square roots of 7 over 2 times 2 is 4. 2 times 5 square roots of 7, that's minus 10 square roots of 7. Then plus 10 square roots of 7. There's that magic happening again, multiplying binomials. And then we get minus 25 times the square root of 49. Yeah, look at that. 5 times 5, 7 times 7. And square root of 49 is indeed 7. So this is actually 25 times 7. Square roots cancel. So let's see what we really have on the bottom here. 4 minus 175. Wow. 4 minus 175 is negative 171. Let's go ahead and write this out. Okay, there we go. Okay, so now can we top and bottom? I think a 3 goes into 171. Let's double check that. This is 3 times Yeah, that's 3 times 57. That's crazy. So we can take a 3 out of here and a 3 out of there, and we're left with a 57. That was a tricky one. That was not obvious. So now we can distribute that in and have just a normal 4 minus 10 square roots of 7 over, let's write that out as a 10, good, and negative 57. Okay, so you could write it like this. The negative could come out here in front or go up on top, and you could also have negative 4 plus 10 square roots of 7 over 57. So the negative being on the bottom or out in front, or could be distributed to the top, same exact thing. Okay, number 43. Multiply by the conjugate 4 plus the square root of 13. And on the top and the bottom, 4 plus the square root of 13. And we're left with 4 times 4 plus the square root of 13 on the top. And then multiplying the bottom binomials, 4 times 4 is 16. 4 times square root of 13, that's plus 4 square roots of 13. Minus 4 square roots of 13. Once you get used to this, you may realize we don't even have to do those middle terms. And then minus square root of 13 times 13, which is 169. And yes, that becomes a 13. So we get 16 minus 13 is 3 on the bottom. And on the top, we can distribute that 4 into 4 plus the square root of 13. That's 16 plus 4 square roots of 13. So we get 16 plus 4 square roots of 13 all over 3 as our final answer there. Okay, number 44. Multiply by the conjugate, 5 minus the square root of 6. 5 minus the square root of 6. And we're left with, let me see, on the top, 5 times 5 minus the square root of 6. Good. And on the bottom, we have 5 times 5 is 25, minus 5 square roots of 6, plus 5 square roots of 6, which cancel, like always. And then minus the square root of 6 times the square root of 6, that's the square root of 36, which is 6. Square root of 6 times square root of 6 is 6. So 25 minus 6 is a 19 that's on the bottom. Let's write that out. And 5 won't cancel with that, so we're safe to distribute. 25 minus 5 square roots of 6 all over 19. Boom. Okay, and the final one. Number 45. We're going to multiply through by 3 plus 6 square roots of 5. 3 plus 6 square roots of 5, the conjugate there. Really a conjugate is its partner to allow both ends to square, which for this purpose, if you square both of these terms, you come back into the rational world, which is what we've been working on, is rationalizing these denominators. So on the top, we get 2 times 3 plus 6 square roots of 5, okay, over 3 times 3 is 9, plus 18 square roots of 5, minus 18 square roots of 5. Those are the middle terms that, yes, indeed, cancel. And then minus, let's do this right, 6 times 6 is 36. Square root of 5 times square root of 5 is the square root of 25, which is 5. 36 times 5, that's minus 180. So if we go ahead and jump this in, we get 6 plus 12 square roots of 5 all over 9 minus 180. That's negative 171. Oh, that's really uncanny. We got that twice. Wow, that's kind of weird. All right. Ooh, and we know 3 goes into this. And, ooh, shoot, we should have taken a 3 out of the top here. Okay, so we can take a 3 out of the top, and that's 2 plus 4 square roots of 5. Okay, and the 3 can cancel with the 171 and leave a negative 57. So we get left with 2 plus 4 square roots of 5 over negative 57. So it could be written like that. The negative, if it looks better to you, you can put the negative up on the top instead of on the bottom. So it would equal negative 2 minus 4 square roots of 5 all over 57, and that would have been perfectly all right to write as well. Good.